Welcome to this session on business mathematics. My name is Ashish Jain. I'm an assistant professor at the Department of Computer Applications at the Bhopal School of Social Sciences. So let's begin this module. In this module, I would be covering how to solve different types of problems in logarithms and their solutions. So let's begin this session. Now let us see some rules to find mantissa. We make use of log tables to find mantissa. Now here are some rules. First rule is, ignoring the decimal point, use the digits irrespective of the decimal as a single number. Second point, in case of more than 4 significant digits in a number, we round off the number up to 4 significant places, and we also ignore the zeros if they are not significant. For example, we have a number 38.456, which is rounded off to 3846 because the last number 6 is more than 5, so we have to round off to a higher value. And finally, we will consider only the 4 values without the decimal, that is 3856. In the number 86340 and the number 0.8634, we have rounded off to number 8634 since the 0 is not significant. But in number 80351, 0 is significant as it is in the middle. So we have to consider this. Then we have to round off the number to 8634. The next property is the first 2 digits were used for determining the row position and the last 2 digits are used for main value and the main difference part. Proceeding along that row till the column in the main body of the third digit is reached. Read off the values from that row and column position. Again, proceeding along the row till the column of the main difference part for the fourth digit. Read off the figure in that position to get row and column value. Add the 2 values that we obtained in step number 4 and step number 5. We put a decimal point before this total answer, and this is the required mantissa of the common log. Now let us see an example. We have the value 34.56. We need to find the log of 34.56. In finding log, first we have to decide 2 values. First is characteristic, second is mantissa. For characteristic, we have some rules, and for mantissa, we make use of log table. So here in this question, the characteristic value is 1 less than the number of significant digits. Here, the significant digits are 2. That means our characteristic is 2 minus 1, that is 1. Now, for mantissa, we make use of log table. Now we reduce the given number into a 4-digit value as 3, 4, 5 and 6. Ignoring the decimal point. Now in the log table, the figure corresponding to row number 34 and column number 5, the value is 5358. We note down this value. Again, we'll take the same row number 34 and we move on to the column number 8 in the mean difference part and note down the value. The value is 8. We add these 2 values, that means 5658 plus 8, so we have the value as 5386. Here we put a decimal point before this answer so that our answer becomes 0.5386. This is the required mantissa. We already have the characteristic value. Now the log value is combination of characteristic plus the mantissa value. That means log of 34.56 is equal to 1.5386. Now we take another example. We have to find log of 128.88. Okay. Now, first we have to find the characteristic value. The characteristic value here is 3 minus 1, which is equal to 2, since we have 3 integer digits in this number. Now we have to reduce this number into a 4-digit value to find the value from the log table. This is a 5-digit value. Now we have to round it off. Since the last digit is 8, I can round it off as 1289. Now, using this value 1289, we will find the value of mantissa from the log table. Let us see how. Now the figure corresponding to row number 12 and column number 8 in the main body is equal to 1072. Similarly, the figure corresponding to row number 12 and column number 9 in the mean difference part is 31. Since the third value is less than the fourth value, so we consider the value as 31. Adding both the values, we have 1103. Now, putting a decimal before this value, we will get the mantissa as 0.1103. Hence, the logarithm value is log of 128.88 is equal to 2.1103. Here, I would like to mention that in certain books or certain log tables, you won't get two different values. Instead, you will only get one value. We will use this comparison of third and fourth digit in the log tables in which we have two different values. Otherwise, whatever values are given, we will take it as it is. The next example, we need to find log of 243 to the base 27 without using log table. So we have to find log of 243 to the base 27 without using any log table. In such questions, what we need to do, we need to apply the concepts and logic of logarithm to solve the questions. Let us see the solution. Here, let we suppose that log of 243 to the base 27 is equal to x. Now, by the concept of logarithm, I can write this as 27 raised to power x is equal to 243. If you remember this with the normal condition, that is log of n to the base a is equal to x, it can be written as a raised to power x is equal to n. Hence we have 27 raised to power x is equal to 243. Now we can write 243 in terms of powers of 3. That means we are finding the factors of n. Just try to divide it as if we are taking a simple LCM. We will get that the factorization of 243 in terms of 3 is 3 raised to power 5. We also know that 27 can be written as 3 raised to power 3. Putting the values, we have 3 raised to power 3 whole raised to power x is equal to 3 raised to power 5. That means 3 raised to power 3x is equal to 3 raised to power 5. Now, we have seen that in indices, if bases are same, powers are equal. That means the value of 3x is equal to 5. Now, the value of x is equal to 5 upon 3, which is equal to 1.6667. Hence, the value of log of 243 to the base 27 is equal to 1.6667. I hope you understand this concept of using the properties of logarithms to solve questions without using any log table. Let us take another example. We need to find log of 1008 to the base 12 root 7 without using any log table. Let us see how. Now, first of all, we need to substitute that the value of log of 1008 to the base 12 root 7 is equal to x. Again, by using the concept of logarithm, we can write it as 12 under root of 7 raised to power x is equal to 1008. Now, reducing 1008 in terms of factors of 12 and 7, in the rough we can solve it. We have 1008 divided by 12, that is, we have 84. Again we divide it by 12, we get 7, and again divided by 7, we get the answer as 1. That means the factor of 1008 is equal to 12 into 12 into 7. So we have 12 into 12 into root 7 into root 7. We can write 7 as root 7 into root 7. So we can also convert it as 12 root 7 whole square, which is equal to 12 root 7 raised to power x. Since bases are same, the powers are same. That means the value of x is equal to 2. Hence, the value of log of 1008 to the base 12 root 7 is equal to 2. The next question. If logarithm of a number is minus of 7.377, then we have to find characteristic and mantissa. Okay. We can write it as minus of 7 plus minus of 0.377. So here our mantissa is negative. But please remember, in logarithm, the characteristic value can be negative, but the mantissa value is always positive. So now here we need to first make the mantissa positive. How do we do that? We have to add and subtract 1. Let us see how. So we have minus of 7.377. It can be written as minus 7 minus of 1 plus of 1 minus 0.377. If I subtract minus 0.377 from 1, this decimal part can be converted into a positive value. So we have 0.623. Minus 7 minus 1 is equal to minus of 8. The characteristic part can be negative. So we have minus 8, or we can write it as 8 bar. Hence, we have the total value as 8 bar 0.623. Hence, our characteristic is 8 bar and our mantissa is 0.623. Now the next problem. If log of 2.768 is equal to 0.4472, then find the value of log of 0.002768, and the value of mantissa is 0.4472. We know that numbers having same significant digits and in same order have the same mantissa. So, on comparing the given number, that is 0.002768 with the given number 2.768, we found that both the numbers have same digits and in same order. Therefore, mantissa of the given number, that is 0.2768, is equal to the mantissa of 0.002768. Now, the characteristic is equal to number of zeros immediately after decimal plus 1 with a bar sign. Here we have 2 zeros immediately after decimal. That means 2 plus 1, 3. We have to put a bar. That means our characteristic is 3 bar. Hence, the logarithm of 0.002768 is equal to 3 bar 0.4472. Let us look back and see what we have covered. We have started with the concept of logarithms. We have seen the uses of logarithm. We have seen the properties of logarithm, rules of logarithm, how to find logarithm of a number using log table. And also, we have seen some numerical problems of solving logarithms. This is the first module of logarithm. I hope this session is beneficial for you. Happy learning. Thank you.